Hello, my name is Billy Efik. Today we are going to be looking at um, pluggable database. That's multi-tenant database architecture that was introduced in Oracle 12c. And we will be in the 19c version of Oracle, though almost everything that is in the 19c is the same as 12c. Going forward, when Oracle releases Oracle 20c, all Oracle databases will be pluggable. We will not have uh, the feature that allows us to install Oracle in a non-pluggable way. So in this demonstration, I want to highlight the features of the multi-tenant architecture, and then we will install Oracle 19c as a pluggable database on an ASM Diskgroup. Again, my name is Billy Efik. I'm an Oracle certified expert with areas of specialization, including real application cluster, grid infrastructure, Oracle Enterprise Manager, cloud control, and data guard. Now, if you are, of course, by now you are used to the different labs we have for this training. This is LAB02C, install and configure Oracle Database 19c on a Linux server. Like I said, this will work for 12c as well as 19c and 20c when that is released. We're going to do this on a Linux server. This will allow us to explore the ASM Diskgroups and use the CRS and the SRV commands. The grid infrastructure 19c is already installed on the server and is owned by the grid user, while the database is going to be owned by the Oracle user. So the prerequisite to this particular lab is that you will have done Lab 1A and Lab 2A, install and configure whether it be Oracle 11, 12, or 19 on Windows as well as on Linux, with more emphasis on Linux. Now, just to give you a brief overview of what pluggable database is all about. What we have is a database called the root container. So first of all, a database called the root container is installed, and then other databases called the pluggable database are installed and they are connected to the root container. Now, the advantage of these are many, and I'm just going to touch on a few. In order to really fully understand what this is all about, we need to go back to the normal, regular architecture of an Oracle database. So I'm going to log into a server just to show you a few things that differentiates a pluggable environment to the regular way we've been installing Oracle. So on this server, if I were to check what databases have been installed in my Aura tab, so we see that 3 databases have been installed. The first one is PTDB, and this is the Oracle Home, it's 11G, PTProd, which is 12C, 12.2. Now we have a second database using the same exact Oracle Home. So for now, just forget about the 11G one for now. Let's assume we have 2 databases on this box. So when we have 2 databases on this box using the same Oracle Home, what's going to happen is that each database is not aware of the other. They cannot use common features. Let me turn on the second database. Let me start the second database just to give you an idea. So each of these databases are not aware of the other. So I log into this database, I start it up. It's mounted right now and it's open. Now, at the operating system level, let's check how many databases are running in this box. Grep Pimon. So we see that database is running. PTProd, which is also 12C, is running. I said ignore the 11G. So we have 2 databases running on this one server. They are not even aware of each other. They are contending for resources. For instance, if I were to grep for that second database, PTCDB prod, take a look at all the background processes spawned by this database. So each of these background processes will take up resources in terms of memory. Now, the second database, PTProd, will also have its own, the background processes also running, completely unaware of the other database. Now, of course, we don't have unlimited resources on this server. It means that there will be contention between the 2 of them. And so Oracle took a decision, okay, how about we create one database and call it the root container. So we create one database instead of 2 and call it the root container, and then each database, PTProd, and then the other database, will become a pluggable database. Now, the effect of that is this. That in our Aura tab, there will be only one entry, which is the entry for the root container. So the root container will be in our Aura tab. Then the background processes, even if we have 10 pluggable database, we will only have one background process, which is the one for the root container. Therefore, we have saved on memory substantially. All right, now let's talk about this picture here. So what we are going to do is that the 2 databases are going to become pluggable. there will be a root container, which is a database by itself, but it's just a container that will hold the pluggable databases. The seed container is actually a pluggable database that is deployed automatically, which becomes like a template which can be used to create a pluggable database. All right, let's move forward. So another advantage of having this multi-tenant architecture is that a whole lot of things can be shared. For instance, we can decide not to have the undo table space for each of the pluggable databases. So the undo table space will be in the root container. The archive logs, the redo logs are now in the root container, which means that even if you have 400 pluggables, they will all be sharing the same archive log, same flashback logs, and save a ton of space. Now, each pluggable will have their own system table space, sys-awk table space, and their individual data. Now, if we, the number of pluggable databases that can be held in a 12C, 19C environment is 253. So we have one root container and 253 pluggable databases. Now, if we are in the Exadata cloud, Exadata infrastructure, we can have 4,096 pluggable databases. That's substantial. Looking at the fact that from the operating system point of view, you will only see one database, being the root container. Everything else will be managed inside the root container. For this lab, we have a machine called, a virtual machine called PT Advanced Server. It has 4 gig of memory. You can give, if your laptop or your machine has a little bit more, you can give it more, but 4 gig will do it. And it has multiple hard drives because we are implementing ASM storage. So the 200 gig will be the main hard drive for this server, and the 10 gig, 50, and 50 will be ASM storage. And ASM is already configured on this server. Let's go take a look at the server. So here's the server right here. And if we take a look at the settings, so we see that same setting. Of course, you can always give the little more memory. So this is the server PT Advanced Server. And and it's running grid infrastructure 19C already installed. So this is the spec of the server. Ensure that you change the password to agree with this for the grid user and for the Oracle user. Now, I have connected with using secure CRT. So I'm going to connect using secure CRT. LAB02C. I'm going to connect as the root user. And to change the password, you just type PASSWD grid. And then you provide the grid password as indicated in the lab. So ensure you stick to this password so that the class will be together. All right, so I'm going to change mine. Because the password contains the word grid, seems to have a little problem with it, but it should work. Let's stick to that. Now I'm changing the Oracle user password. Next in the lab, ensure that the IP address is the right one. All right, what is my IP address? ifconfig so my IP address is 192.168.1.186. Let me check my host file. I think I already fixed that. All right, that's correct. If yours is not correct, fix it. Make sure it conforms. Now, do not touch this line. We will be dealing with that sometimes later. This same server will be used as the primary database for one of our labs that is upcoming, Data Guard, Oracle Active Data Guard 19C. All right, so now next, I'm going to check that all my disks are visible at the OS level. Now, when you copy paste these commands, sometimes they get a bit messed up. Okay, so I'm going to type it. Disk /dev, show me all the /dev, hd drive B to E. All right, so it shows me all the disk, 10 gig, 50 gig, and 50 gig. Yeah, I know it says 53, but it's actually 50. All right, so these are the physical disks that will be used for ASM. All right, let me do an ASM scan. Oracle ASM scan the disk. So now these disks have been configured for the first command I did, the fdisk, was just showing me the disk at the operating system level. Now I want to see when the disk has already been marked with ASM format, and the scan takes place, and I'm going to list it. And it displays the ASM disk, 3 disks, mapped to each one of these disks. Now, if you don't have this result, please do not proceed. It says to reboot the server. You can go ahead and reboot the server. All right, I am moving on. All right, here's what we want to do. So, advanced server is the name of the server. This is the domain name. Please do not change the domain name. The grid infrastructure, the Oracle seed is plus ASM. Let me quickly log in as the grid user. I've defined a connection as the grid user, and then the other connection, grid. Let me also connect as the Oracle user. Because I just changed the password, okay. So as the grid user, if I take a look at the seed, cat.bash underscore profile. So you see that this Oracle seed is plus ASM. We can also take a look at that in our Aura tab. Cat etc Aura tab. So we do have an Oracle seed plus ASM, and this is the Oracle home for the ASM instance. So ASM instance is already installed, but there's no database. So the grid listener will be running from the grid home. So we will not need to create another listener. So the database will register with that grid listener. We are going to create a root container. So when it comes to the database, our Oracle seed will be PTCDB, container database, and then the global name will be ptcdb.domain. This is like if you work for CNN, you could say ptcdb.cnn.com. If you work for Bell South, you could say ptcdb.bellsouth.net. So that's like a domain name of an actual company. And then the pluggable databases will be ptcrm01.domain, ptuat01.domain. So these will be pluggable databases, and they will be on the ASM Diskgroup. Now, the first Diskgroup will host the grid infrastructure resources like the CRS and the rest of the grid infrastructure resources. Then the data file will be in plus data. Our FRA will be in plus reco. The grid infrastructure will be owned by the grid user on the operating system level, while the database will be owned by the Oracle user. And these are the group permissions. All right. Now, first of all, let us explore the ASM instance. Let's explore. We have already seen our Aura tab, that first query. We were able to see our Aura tab. But let's log in as the sysASM. Go here, SQL plus /as sysASM. So this is the ASM user, the ASM owner has just logged in as the sysASM. This is the ASM instance. Its purpose is to manage this group. It's part of grid infrastructure. All right, let's type this query. Select instance name status from $instance. Select instance name status from $instance. So we see this is the ASM instance. It has started. Let's find out what these groups we have. Now be careful how you copy paste these queries. I would prefer that you paste them in Notepad first to be sure that special characters have not been added from the PDF. Paste that. So here we have 3 disk groups. Inside grid infrastructure, this first one is called CRS. The other one is called data, reco. And this is about 10 gig. This is 50. And these are the actual ASM disk that these disk groups are mapped to. Of course, we can add more disks to each of the disk groups. So this is the name of the disk group right here. And this is the actual ASM disk that they are mapped to. Let's also take a look at the ASM command line utility. So the ASM command line utility, ASM command. So this is the ASM command line utility, just like SQL Plus, and we can do something like list the disk group. List the disk group. So these are the disk group once again, same result, and the sizes of the disk group. There's the size. How much free space do we have for each disk group? Another utility I want to quickly showcase is a GUI tool. And because it's a GUI tool, I'm going to log into MobileXtem and invoke that GUI tool. Start a local terminal here. Now, it's not as if CRD cannot display GUI. It just needs a little bit of configuration, precisely installing an X server. But MobileXtem already comes with an X server. SSH, the grid user, and the IP address. I'm going to provide the password. Okay, I just changed it, so. Okay, good. I'm going to save this password. So I'm logged into the same server as the grid user. And I'm going to invoke ASMCA, ASM Configuration Assistant. Of course, by now you know the drill. When you invoke a GUI tool, it can just come and sit on the taskbar right here. So there it is. ASM Configuration Assistant. So I can explore the ASM environment. So the ASM instance is running, and these are the disk groups that we just displayed. And if I click on each one of them, it can tell me a whole lot. Same information right here. Okay? We can mount it, we can dismount it. We can also mount and dismount it with command lines using SQL Plus command line. Exit that. Let's take a look at the grid listener. SRV CTL config listener. This is the configuration of the grid listener. The grid listener is called listener by default, and this is the Oracle home, and it's listening at 1521. We can always add ports to the grid listener, but that's out of the scope of this lab. And the listener is enabled, meaning it's running. Now, I'm going to use a lot of SRV commands, so begin to get used to SRV. SRV CTL status. I'm going to check the status of the listener. So first I looked at the configuration of the listener. Now I'm checking the status. It says it's enabled. What do you mean by it's not running? All right, let's check the listener status. Listener control status. Yeah, the listener is running. And it's listening at port 1521. There is no database, that's why it says the listener support no services. There's no database installed yet. All right, we're still exploring the grid infrastructure environment. Now, one of the most important commands in a grid environment or rack environment, wherever you have ASM, is this command. You must know this command. It actually tells us the status of all the CRS, all the infrastructure, Oracle infrastructure in this grid environment. So it's actually CRS-CTL status resource -T, tabulate it. That's the command right there. Status of all the resources -T tabulates it. Another way to write that is CRS-CTL start res -T, status resource -T. All right, now what does it tell us? It tells us here are the disk groups, DG for disk group. So data disk group, record, and then the grid listener is online. The disk groups are online, they are stable, and some other GI components like all these. The explanation of all this is beyond the scope of this lab, and this tells us that the ASM instance is started and stable and running. Now, if we have a database, it will also be listed here, because once we install the database, it will register with grid infrastructure so that when we reboot this server, Oracle restart will automatically start everything, or even if we don't reboot it or something makes the database go down, it will be restarted automatically by grid infrastructure. All right. So let's proceed with, now we want to install a pluggable database, and I said that in your .bash_profile, only the root container will be indicated. So from the operating system, only the root container will be visible. All right, let's go in as the Oracle user. Let's take a look at our .bash. So we need to fix this. We need to fix this. That's not correct. vi.bash_profile. So this database will be called PTCDB. That's what it is in the lab. Please stick to it. PTCDB. And I'm just going to save this, escape, right, quit. Now, the fact that you changed it in your .bash doesn't mean that it has taken effect. So you may want to exit and log back again. Although there's no need for that, I can run the content of .bash automatically by doing a dot space and the name of the file. That sets my environment. Let's check that environment variable. Grep Oracle. So we see that the Oracle C has been set to PT CDB. And then this is the host name. This is our Oracle base and our Oracle home. All right. Now that we are ready to start the installation of the database, I want you to take a snapshot of the virtual machine so that you can always go back to this position if something gets messed up. Now, of course, in the real world, you don't have the pleasure to do this, but this is training. All right, I'm going to take a snapshot, VM, snapshot, take a snapshot. What should we call this snapshot? Ready for Oracle Home. All right, that was quick. I took a snapshot already, just to confirm that the snapshot is now there, ready for Oracle Home. So we can always go back. Now, we are going to install the Oracle Home software only. If you've been following this training, this shouldn't be an issue. This should be a cakewalk. Let's go and see, do we have the Oracle binaries, Oracle software already staged? LS. No, we do not have it. Change directory, $oracle_home. So we don't have the software. Well, you can download the software from the Oracle website, or you can do a secure copy from the cloud server in the class cloud server. I'm going to just do a secure copy from the cloud server of the class. There we go. Cloud server. So in the resources folder, we have 19C zip, change directory, zip. So this is the zip that we want to use. And I'm going to directly copy that from the cloud server. Why don't I make a directory stage where the zip file is going to be. Secure copy. Log in as you. Of course, that will be your username. When you get there, go to this folder and copy the zip file, star.zip. Bring it right here. And you will be asked to accept that this connection is fine and that you have the appropriate password. So this is your cloud server password. Now this will take a minute to download. While that is cooking, let's go and see if there are other things we can do. So we're gonna, once we unzip it, we are going to unzip it into the Oracle Home, and then we're going to run installer, and we will follow through and install software only. Let's see anything else we can do quickly. Um, all right, we can take a quick break at this point and allow the download to take place. 8%, not bad. All right, so the download is complete. So we now have the zip file. We are going to unzip it directly into Oracle Home. And please ensure that your Oracle Home is properly set. Echo dollar Oracle underscore home. Okay, so we are going to unzip the installation disk right there. So we're going to unzip it in Oracle Home, dollar Oracle Home. All right, the unzip is complete, and the lab says to go to Oracle Home and then run installer. So we go in there, change directory, dollar Oracle underscore home, and here are the files. We're gonna do run installer. Of course, this is a GUI. So I'm just going to go here and do another connection as the Oracle user to that server, 192.168.1.86. Change directory, $Oracle. Of course, I'm going to check my environment variable to be sure it's all lined up. Grep Oracle. All right, that's my environment variable, very correct. Change directory, Oracle underscore home, and run installer. All right, this is Oracle 19C. Ensure that it's 19C that you are invoking. Oracle 19C database. We are going to install software only. Single instance. This is not a rack. Enterprise edition of Oracle. Our Oracle base and watch that Oracle home right there. Make sure it's correct. Pick that value from an environment variable. This can be left as default. We're not going to automatically run the configurations, the root script. We're going to manually run it. It's checking and ensuring that our Unix server meets all the requirements, the packages that need to be there. We can do a yum update to update these packages, but these ones are really not a showstopper, so I'm going to ignore them. and then we install. A yum update can fix that kmod package. So the installation has begun. Right, our installation has gotten to the point where we need to run the root script, run that as root. Accept the default. And then we can come here and click OK, and the software has been installed. All right, so we have installed the software. So we do have Oracle Home already installed, and then the lab says to do a second snapshot, indicating that we are ready. Now that we have installed the software, we are ready to go ahead and install the database. Snapshots just allows us to find the right server. Snapshot allows us to go back if we messed up, or we can go back to the very beginning and do this all over again. Okay. All right, so I will pause the part 1 here. We have installed the software only, and now we are going to use DBCA to install the Pluggable database.